This is the first of a series of videos to explain the interpretation of ECG, and I think I will have to start with talking about the principles of generation of positive and negative deflections of the ECG, because I think without this basic understanding you'll always be trying to memorize the different patterns of ECG instead of understanding them. So here we have an example of an ECG lead, and I've chosen lead 2 because it is a lead that is closest to the axis of the heart. And all leads have a positive and negative pole, and an action potential will always travel from the negative to the positive pole, just like a battery. The inside of the lead is all negatively charged because the resting potential of the cardiac muscles are approximately negative 90 millivolt, which is a polarized state. If I link it to this galvanometer, it will help reflect the positive and negative deflections that we will see on the ECG strip. And currently it is pointing at the 0 mark and not negative 90, because a galvanometer measures not just the intensity but also the direction of current, and right now there is no current. Now let's look at diagram B. If we stimulate the negative pole of the lead by opening the ligand gated sodium channels that happens physiologically to enter the muscle, once they go over the threshold of approximately minus 55 millivolt, more voltage gated sodium channels will open and causing an action potential, and this will shoot up to a positive 30 millivolt, causing a depolarized state. So as you can see, the positive charges are going from the negative pole to the positive pole. And then now look at diagram C. When one end of the muscle or the lead is stimulated, the depolarization will pass on to its neighbors towards the positive pole, and this will cause a positive deflection on the galvanometer, hence a positive deflection on the ECG as well. So rule number 1, a positive charge moving from a negative pole to a positive pole will cause a positive deflection. Now let's look at diagram D. Now what comes after depolarization will be a repolarization. And pay extra attention to this, because when repolarization happens, negative charge goes from the positive pole towards the negative pole. And in this situation, it will lead to a positive deflection also, because negative charge going towards the negative pole is negative negative, it gives you a positive. And this explains why the T wave on the ECG is a positive deflection on lead 2 and not a negative deflection. And one might ask, why is repolarization not going from the negative pole towards the positive pole? Because this leads to our rule number 2. Whichever part was the last to depolarize will be the first to repolarize. Therefore, the repolarization will go in the direction of the positive pole towards the negative pole. And the rule number 3 is that a negative charge moving from positive to negative pole will give you a positive deflection. Now let's consider another scenario. Diagram E is our resting state once again, and diagram F, now we'll stimulate the other side of the pole. So if we stimulate the positive pole, and the positive charge goes from the positive pole towards the negative pole, we will get a negative deflection. And this leads to our final rule. A positive charge moving from positive to negative pole will give you a negative deflection.